Hello, this is Geometry Proofs Day 2 notes. This will be on 10/30/15. So now we're getting a little bit fancier. We're given that angle 1 is congruent to angle 4, so make sure you label that right away. And you're also given that XZ bisects angle WXY. Remember, what does each given give you? So XZ bisects this large angle. So that by labeling the diagram, it sort of outlines that angle WXZ is congruent to angle YXZ. Because if angle is bisected, then two congruent, I'm just going to squish that in, angles. So remember, our ultimate goal is to get to triangle WXZ congruent to triangle YXZ. And we have to take a look at our two triangles and see how we can get there. Right now, all I have is an angle in the triangles. I know I can get a side congruent because XZ is congruent to XZ by reflexive property. Bink, bink. And I basically want to get to that this is angle, angle, side. So you want to kind of take a step back. So these two are supplementary. Angle 1 and angle 2 and angle 3 and angle 4 are supplementary. I'm going to abbreviate that because if linear pair, then supplementary. You could say definition of linear pair, and that's going back to the first chapter. If these two are adjacent and supplementary, they form a linear pair. Adjacent and supplementary. So now think about this. Because angle 1 is congruent to 4, let's pretend this looks to be about 120 and 120. That would mean that this was 60 and 60. So basically, if these two are supplementary and these two are congruent, that tells me that angle 2 is congruent to angle 3 because supplements, I'm abbreviating supplements, of congruent angles are congruent. So think about that. These two would both be supplementary to the same angle. So that leaves these two being congruent. So if you have to plug in some numbers, then go ahead and do that. So then I have this angle, I'll show that by a different tick mark, is congruent to that one. So now I have these two triangles congruent by angle, angle, side. Angle, angle, side. Okay, we're getting really fancy, kind of quick here. Okay, here we have triangle AED is isosceles. Triangle AED is isosceles with base AD. Given. So remember, what does an isosceles triangle give you? Two congruent legs. So right away, I'm going to say AE is congruent to ED. Definition of isosceles triangle. Now some teachers or if that helps you to say, if isosceles triangle, then two congruent legs. Remember, the two congruent legs make up the vertex angle. The other given is AC is congruent to BD. And that's given. Make sure you label your diagram. So AC is congruent to BD. So again, I'm trying to prove that triangle AEB is congruent to triangle DEC. So that's your ultimate goal. So you want to look, here's triangle AEB, here's triangle DEC. I don't know if that helps or hurts showing it shaded. But right now, all I have is a side. But remember, what does isosceles triangle give you? That the two base angles are congruent. I should highlight that or something, but do I have a groovy highlighter? I have a purple marker. So I'm showing that these two are congruent. Angle EAB is congruent to angle EDC, because if sides are congruent, then angles opposite them are congruent. You just had a whole couple days on section 4-5. So now I've got this side, this angle. How can I get this side? I'm going to subtract the same congruent piece. So I'm going to knock BC out of the equation. So I've got AB congruent to CD by subtraction property. Okay, so I can give you a reason sheet next week, but for now, you're kind of going along. Yesterday I gave you the definition of a circle. All radii are congruent, median, altitude. We already knew isosceles triangle. We already knew reflexive, linear pair. So a lot of it is just recalling it. Angle bisected, we know two congruent angles. You're just making it formal in a proof. So don't panic. You can pause the video as needed. The key is to just keep on. What does the given give you? So now these two triangles are congruent by side, angle, side. Okay. I'm going to turn this over. Do our third example. I can zoom in a little bit. And angle R is complementary to angle 1. Okay. There's really no groovy way to show that if they're complementary. I'm just going to have you write it for now. Angle R is complementary to angle 1. Angle W is complementary to angle 2. That's given. But it's similar to the previous page. It's a super ugly given. I'm getting tired. Given. The previous side, which says that supplements of congruent angles are congruent. Now hopefully you're kind of thinking, angle 1 is congruent to angle 2 by the vertical angle theorem. Bink, 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 bink. So if these two are complementary and these guys are congruent, that tells me that angle R is congruent to angle W, because complements of congruent angles are congruent. Complements of congruent angles are congruent. So, what do we got? What else am I given? Oh, S is the midpoint of RW. So that's given. And then I look at my picture and I say to myself, S is the midpoint, so that tells me that RS is congruent to SW. Because if midpoint, then two congruent segments. I'm going to put this in pen so I can fit it. Segments. Don't say two congruent angles. A midpoint is a point in the middle of the segment. An angle bisector is a ray that bisects an angle. Big difference. So now I have these two triangles congruent. RYS is congruent to triangle WGS by angle, side, angle. Angle, side, angle. All right, now you're going to do proofs day 2 homework sheet, and I will see you soon.